So, engineering economic decisions are appearing in a lot of places in the product life cycle or for the company's process. For example, if you are thinking of selling a product, first of all, you need to plan on building the facility. And so you need to come out with all kinds of plans and where to build the facility and how big the facility should be and so on. Then chances are you don't have all of the money, although you can invest some of them. Maybe your partners can invest some of them. You still need to find investment from outside. So this investment plan is also quite important, and how do you provide sufficient information so that the potential partners will be interested in joining the venture. Once you do the investment, then you start to do the building up the facility and doing the manufacturing. So in manufacturing, again, you have a lot of choices that you need to make, and you want to make sure that your product can be profitable. You need to make a lot of decisions, choosing right machine, choosing right materials, choosing right approach to make the product, and so on. And when you do marketing, again, you need to find the right target, of the market, so that you can promote the product more effectively and profit from the sales, and in the end you generate the profit. So these profit come from a lot of process aggregated together, and in each of the processes there will be a financial decision that one need to make. For these decisions that we are talking about, a lot of them are not just something that we have right now. In fact, a lot of things will happen in the future. So we need to be able to predict the future or the relevant information of the future so that we can do our analysis. For engineering economic analysis, basically we may need to consider a constant stream of investment coming into play. So we need to know our required investment and when they will arrive. And it will be based on our forecast of product demand. Right? Certain product will have certain demand. If the demand is small, but the profit margin is very high, then we may still make it. But if the product demand cycle is very short, but the profit is low, then it may not worth of our effort making the product. So we need to forecast product demand time, demand quantity. We need to estimate at what time the selling prices will be, so that we need to introduce the product to the market by certain time. And of course there will be costs, particularly manufacturing costs. Manufacturing costs is not that easy to estimate. We can estimate materials, we can probably estimate labors, human resources, but the kind of machines that we can get and so on. These are something that we need to collect data and estimate. And we also need to estimate product life, as I mentioned just now. How far or how long that we can sell the products. For a very long-term product, I think a lot of investment can be justified. But when the lifespan is too short, then a lot more analysis need to be done. And engineers, basically engineers contribute a lot of technical information into decision making. We know what the product should function, what kind of technologies required, how we can build the product, and there are a lot of technical information required that engineers can provide, so that financial analysts can utilize such kind of information, can come out with reasonable financial plan. And we can look at such kind of decision in many different kinds of project. If you look at a large-scale engineering project, I think if you go to an engineering consulting firm, they build bridge, they build airport, they may build a railroad, and so on. They can build a subway system. All these projects are very big and take a very long time to get finished. So the investment will be very big, and in the future, a lot of things will happen in the future. It's not just the constant return of our investment in the revenue. It's also, as time goes back, our investment may also need to be increased because inflation, because shortage on raw materials or on equipment, and so on. So these information across a very long period of time need to be estimated so that our prediction will be accurate. For example, we can look at a simpler case where we want to produce a product. Basically, it's an auto body panel, and there are choices of material for making the panel. One is plastic sheet metal compound, sheet molding compounds. In short, it's SMC, plastic SMC. The other is steel sheet stock. Okay, these two kind of materials are quite different in terms of the equipment invested to make the panels will be different, and their unit cost will be different. The process time will be different. So how do we evaluate these two and get the most effective way, or cost-effective way, to make the product that require some analysis? If we look at the picture, it basically provides some information of how materials go in the process, and the process will create the final product. This is based on SMC, as we described, plastic SMC. So you cut a piece off, and then you increase the temperature, it melts, and it forms the final result. Okay, and sheet metal, as you may have guessed, you have to sort of press it. So if we want to make a comparison of these two, we need to collect all relevant information. As you can see in the table below, that we can list all the relevant information. So for example, for plastic SMC, the material cost, which is dollar per kilogram, is 1.65. For steel sheet stock, it is lower. But if we look at the machinery investment, steel sheet stock is higher, and plastic SMC is lower. Tooling steel sheet stock is again higher. But when it comes to cycle time, that is for every part of the product that we produce, how much time is going to take, how many minutes is going to take. For plastic SMC is 2.0, 2 minutes. For sales ship stock, it's only 0.1 minute, meaning that for every parts that produce, sales ship stock takes only 20th of the time to plastic SMC, so you can produce a lot more. And if you look at the material cost, it's a lot less expensive, so you can produce a lot more in a much shorter period of time, and with a lot lower variable cost. So it is an advantage of steel ship stock production, although the investment could be quite high. So how do we compare them? As we indicated previously, we need to look at the product lifespan. We look at the potential demand and so on. After we gather all this information, we can probably find a balance point. Usually it is the quantity. If we produce enough quantity, that quantity can average out the higher investment cost. So that requires certain analysis, which we are going to discuss later in this course. And we may also have simple decisions, such as we have some equipment and it has been in use and it's okay, but it's not very efficient. It's a little bit old-fashioned, and maybe it's a little bit slow and so on. And more importantly, it starts to break from time to time. Okay, for example, car engine. And then, should we replace a new one so that our business will not be interrupted, or should we still keep the old one until it breaks? And what is the consequence when the car did break during our operation? So we need to gather this information so that we can make a proper decision and to replace or continue to use the current car engine until it breaks. So basically, it is still a financial decision. And we can also think of product development. Right? Should we develop a new product, or should we just take an old product and expand it? New product has a lot more market potential. Right? It will generate a lot more profit. But any expansion, it doesn't cost too much to produce, and we can still make some money. Again, the decision will be very similar to previous one. That is, we need to take into account of all the relevant information. Particularly, these two decisions may have some break-even point, meaning that maybe below a certain point, one solution is better than the other. Above that point, the decision will be just the opposite. And similarly, in a factory, we often consider using automation, using robots or machines to replace labor. And the decision will be very similar. Initially, we need to invest a lot of money. Is it worth of investing that kind of money to replace labor? If you are not making a lot of the product, the same products, maybe you will just use labor because people are more agile. People can do different tasks. But if your work is fixed, that you need to make them in large quantity, maybe using machine is more reasonable, more profitable for us. And even if we just consider cost reduction, because labor cost is quite high. But then, unless you are the machine that you acquire, you purchase, can be used for various kinds of production needs. Otherwise, we still don't know. We still need to evaluate before we know whether or not by employing industrial robot we'll be able to cut down the cost. And gradually, I think company found out that doing mass production may not be as profitable, although they can make it in a much lower cost. However, we know that customization generate a lot higher profit margin. To do customization, we may need to have an overhaul of our service or our value proposition. So we may need to change our entire process of making and selling the product. Is it worth of doing that? Will that generate sufficient of additional value so that we can profit from the additional volume, deducting the investment cost? The customization in terms of clothing, you can imagine that we need to measure the customers. That will be cost involved. And once we have the measurement, we need to have computer assisted system to turn this measurement into the design of a personalized gym, and that will require cost and skilled worker. And then you have a automated system which can help you to cut pieces of the clothes so that you can later stitch together. Again, that will incur investment. Then you can sell different product to different customer in a much smaller batch, which will require different logistics system, and that require cost. The benefit will be the profit margin will be a lot higher. So there are various issues that we need to bring into consideration before we can make the decision. You can imagine. We need to know, are we going to sell a lot of them because it's more expensive? Will customers buy it? And what will be the potential market size? What is the price that we can set so that we can still attract enough customers? What exactly the cost we are talking about to have an entire system? So all these answers need to be answered before we can make our decision.